So once again, welcome everyone. My name is Weronika Goliszewska and I am Learning and Development Specialist working in GlobalLogic, and I have a pleasure to host today's webinar together with Patryk, who will be our speaker today. So as you can see, you can use a chat if you would have any comments or just would like to say hi or anything. As you can see, you have also the Q&A option, and please use it for all your questions. And after the webinar, there will be a part when those questions will be answered. So please feel free to put all your questions regarding the topic of today's webinar there. So as you noticed, you are muted. And it will remain this way during the webinar, unless you have some question that you would like to ask in person, or it will be hard to ask it in Q&A section, but we encourage you to use the Q&A section at first, unless there will be something not sure for Patryk to answer, we can then give you a voice. Okay, so without further ado, over to you, Patryk.
Thank you, Veronika, and hello to everyone. It's really good to have you all here. I can see that we have 132 attendees and still growing, so I'm very glad about it. It's quite a lot. Maybe not as as much as 14-year-old Minecraft player, but I think for Autosar it is quite some amount. Yeah, it would have been much nicer to meet in person. So it would have been much nicer to say that we can have some beer in the back, we have some snacks, and we can all meet after my talk and discuss Autosar, discuss automotive, discuss whatever we like. But hopefully these times are coming, or coming back rather. But all in all, I am very happy that you're all here. I had a reason, from day to day work at home. I had a reason to dress up, not wear my pajamas to my meeting, and meet you all here. So let's start slowly. Okay, I hope my screen is visible. So, oh yeah, I forgot to introduce myself at the beginning. So my name is Patryk Pankiewicz. I'm a consultant. I've been working in automotive for I think around 10 years now. Most of it in Autosar, most of it in Embedded. I've worked with a lot of different projects, big ones, small ones, mass production ones, prototype ones, you name it, basically. Which I think it kind of tells they like automotive. Otherwise, I would be suffering a lot during these 10 days. Okay, so my name, I said it, consultant. Yeah, okay, let's go. So let's answer some questions for the beginning. Overall, we're going to talk about automotive diagnostics, but let's answer the question number one. Most important question, the question that I've asked myself a lot, the question that keeps you up at night, probably the question that is a technological issue since since forever, basically. The question that all the major companies ask themselves, namely, how to make an ISO norm sound interesting. So I've struggled with it a lot. You have to believe me that before preparation of this presentation, I struggled not to bore you with ISO norm, which is, automotive diagnostics is based on ISO norms. It's the whole automotive is built on ISO norms, since we produce quite a lot of cars. There's a lot of software inside of them, so we need some standardization of it. So yeah, this was my first issue. How do I make it? How do I present it to you guys here, so that you don't fall asleep in 10 minutes? But I have to tell you, I think I found a solution. So my first approach was I'm gonna do the whole presentation based on memes alone. So this is on, you can see on the left, I started to look at memes, but then I was like, okay, there are not that many memes about automotive and Autosar, which is, I don't know, maybe it's an opportunity for a business. I have for a startup to start up like a 9gag for automotive, which is, I don't think it's the best idea. So I was like, okay, we don't have enough memes. So then, fortunately, I got some support from my beloved GlobalLogic Krakow colleagues, which is on the right. So this one, for the non-Polish speaking participants, the picture on the right states, I disconnect the battery and the arrows disappear themselves. So this was very nice for them to prepare this meme for me. I miss you so much, GlobalLogic Krakow. So I hope we can meet soon, and all this will be ended. Let's say all this Corona madness will be ended soon, and we can meet in person. So first idea, memes, not that good. So then I thought, all right, so let's gonna go with such approach. I found this cool slider bar on the internet. So I thought I'm gonna use it. So I put in my slides this geekometer, right? So it's gonna be in the bottom right corner, and it's gonna say green for some storytelling, and I'm gonna try to tell you some stories about cars, stories about software that will align you or that can help you to understand automotive diagnostics better. So green is, haha, hopefully you're laughing, or I'm trying to make you laugh at least. Orange is going to be Autosar. So it's going to be more advanced, it's going to be more serious, it's going to touch some technical topics, but still I will try to make my best, to do my best that you will understand it. I'm not gonna go into technical details. If you have any technical details questions, you can ask me at the end. But I'm going to try to make you understand why we use Autosar, why we use diagnostics, why and how does it work, right? I'm going to focus on this, that you have a overview of diagnostics. And the foie de gras, or the ISO norm, is going to be red. So this, I still have to say it because automotive diagnostics is based on ISO norms, but I will try to minimize it to the minimum, and so that you know where to look, you know what it's based on, but still you rather understand it, know where to find your information. So this is going to be the geekometer on the bottom. Okay, so car software is complicated. Yeah, that's not a discovery of any kind. That's not a revolution or a revelation for you. And most of you probably know that we do have a lot of software in our cars. I'm sure that all of you also followed my Autosar introduction video. If not, there's gonna be a link. They say like on YouTube, there's gonna be a link here. I don't think we can do it, but like Veronica probably will provide you a link. It's on our YouTube, so I think you can find it there. So please watch the Autosar video. It gives you an overview of automotive software, but so it says there as well, the car software is complicated. And to start with a story, I think all know this, let's say, movement, or how to call it, this development of electronics, and it goes also for cars as well as for everything else in your life, and your household appliances, your fridge, your TV. So a couple of years ago, it was much simpler, right? There were less electronics, less software. Everything was just simpler, right? And then at these times, first of all, it was much easier to fix something, and then it was much easier also to make it reliable, right? I think you all remember. I still remember that my grandma fridge it just works. Like I had 4 fridges in the same time, where my grandma had this one, and it just cools. And I did it. It doesn't have these cool fancy features that like you have a huge tablet in front of your fridge, but then I can deal with that since it doesn't break all the time. So what I wanted to say is that it was a couple of years ago much simpler, right? And then we had some progress, right? So if it broke, we still had some electronics with it. We ordered a guy. The guy came. Probably he said, "Oh, your fridge broke, and you need we need to exchange the control unit." The control unit was always because they didn't know what to do with it, so they just exchanged the control unit, and then we became the experts, right? So I think it was in the slide before here. We used the ultimate tools right on the left. So we used Google. We used some basic tools. We used some soldering iron, and we said, "Aha, I'm gonna fix it, right? I'm gonna take my soldering iron. I'm gonna Google. Okay, why does my Samsung fridge breaks down, right?" And it said on the internet, well, probably the resistor, the capacitor, the thermal detection meter, it broke, and then you can buy it for $3, and then you can replace it yourself, right? So this was a time that we all felt good that we fixed something with our own hands, and then it also was similar to automotive, right? So in cars, a couple of years ago, there was the times of mechanic, where most of the car was mechanics. Then we got more and more electronics, right? So we started to introduce some software to cars. Then it was better and better. So overall, it helped a lot, right? We have the ESP, we have the ABS, we have all the car assistance systems now. I mean, now it's like this that I thought about it a couple of days ago that I thought about I'm gonna buy a new car, right? So then I was like, my dad asked me, like, he was like, okay, so you're gonna buy a car, so what engine does it gonna have? Like, what's it gonna be? And I was like, well, the engine, right? Well, I have to think about the engine, but what I do know is which infotainment it's gonna have. What I do know that I want for the car to integrate with my cell phone, right? What I do know is that I want to have the cruise control that is automatic, and then I can just set it on the highway and it drives for me, right? It's already there. So it's kind of a different thing right now, right? So we have all these features, but then again, we have also the danger that the more complicated the product, the more we need. First of all, the more effort we need to make it reliable, and second of all, the more information we need from the car to retrieve more information from the car to understand what's going on, right? I had, but maybe more about this later, not to tell stories all the time. So car software is complicated. Yeah, no news here. So let's move to automotive diagnostics. I mentioned a bit about retrieving of information from the car. I mentioned a bit about reliability. So what does automotive diagnostic actually means? Well, what it means is that we need to know a lot of information about how the car is doing, right? Over this presentation, I try to compare it to a human being, since cars are part of our lives. So I'm going to try to compare it to our body, right? Okay, so let's go. First of all, what we need. So if we go to the doctor, right, we feel sick, we feel bad, we have some problem, then we go to the doctors, right? So first thing the doctor does, he takes it, or she takes her stethoscope, and he sticks. He doesn't stick it anywhere. He's just he feels us up, and then he checks what information can he retrieve from our body, right? If the stethoscope is not enough, he's doing some blood tests. He sends us to an MRI or anything like that, right? So to compare it to our cars, the stethoscope is the stethoscope doesn't have to be 16 centimeters from the steering wheel. The OBD2 connector does. So the OBD2 is a standard. It's a norm that has multiple elements with it, but one of them is the connector, and a definition of how the connector should look like. It's well defined by the standards that all the cars that are currently produced, they have to have it. They have to have it in 60 centimeters from the steering wheel. So every one of you, you can Google it. I think, yeah, you can Google the OBD location in your car. This is just an example. What is interesting is when you type OBD location, most of the cars that show up here are French. I mean, no offense to anyone, but that's just how Google. I use the incognito mode for this, so it's not like I have a one of these cars and it was influencing my results. So we have the stethoscope, we have the port that can allow us to retrieve some information from our car, right? We start with that. Cool. Okay. So we've got the OBD2, and this is a lot of information. You don't have to remember, I mean, none of it really. I'm showing it to tell you what is inside of it, what is important. So what do we see here? We have first that first information, we do have battery voltage there, because if we stick some device to it, it can be powered from the OBD itself, right? So we can have the battery voltage there, number 16, I believe. Then we have the grounds for chassis and our signals, but this is maybe less relevant. What is relevant is we have Ethernet. This is one way of communication with our car. So on the pins, I think 13 and 12, we have Ethernet pins, and it says diagnostics over IP. So this is allowing us to perform the diagnostics to our car with the use of Ethernet. Also, we have on the pin 6 and 14, and we have CAN. So CAN is another communication bus and allows us to retrieve information from our car. And on all these pins, the other ones, we have additional signals that might be OEM specific, so car manufacturer specific. So as you can see here, Volkswagen has some, Volkswagen and Audi, I mean, well, they're both Volkswagen money, but let's say Volkswagen and Audi as brands, they have some additional signals on pin 1. So we have part of it standardized and part of it, it's custom for each car manufacturer that retrieves some data. So we have first the stethoscope, our OBD2. You can Google it, you can find it in your car. You can try to connect to it with what? I will get to it in a second. Okay, so as we all established, and as you all seen on on my Autosar introduction video or webinar, we do have a complex network of units in the car, right? In a modern produced car, it's around, I would say 100, 120, depending on how complex the car is and what options do you take when you buy the car. So, well, we have 100 little computers in our car, and we have one stethoscope, one OBD2 connector. So how do we get to the other units in the car, right? How do we get from the connector to the back, to the parking sensors, to the infotainment, to any other unit? Well, it is possible due to our architecture that is shown on the slide here, that we have gateways. So we communicate with one gateway and we ask, hey, I heard that this car has a airbag unit. I know its address. Do you know anything about it, right? So the gateway says, yeah, I know about it. It's, this other gateway is talking with the airbag unit, right? So your message travels throughout the car and looks for the looks for the end unit. So in this way, you can communicate with most, I would say almost all of the units of the car. Naturally, you need to, there are a lot of security features on the way, so you cannot just ask everyone about the data and all the information that you need. But the way of operation is that you connect to the OBD2 and you retrieve some information from the car, right? So we have our tool, we have our stethoscope, and I think this was an orange light. It was supposed to be an orange light. So an orange light is always, I try to follow an orange light with a green one. So I don't know if we have any science fiction fans here. Well, but we come to the next question. So the second question that I wanted to ask is, or answer rather, is the ultimate question of life, automotive, and everything. So if you do know that the question to life, universe, and everything is 42. When we get automotive in perspective, the answer is obviously 4.4.0. So when we're speaking about Autosar already, let's recap. I mean, again, I know you were on my webinar about Autosar, but just to remind you, if you forgot, what is Autosar? I know that all of you are interested in Autosar Toruń. I mean, at least all the Polish speaking participants are interested in Autosar Toruń. I was as well. I Googled it, obviously. It was my first choice. It's a company. It's not an automotive company. It doesn't have to do anything with Autosar or maybe, well, I don't know who was first, this company in Toruń or the actual Autosar. I've read some opinions though about the owner. He doesn't treat his workers quite nicely. So yeah, there's that. But back to Autosar, the automotive one that we do want to speak about. So Autosar provides, it's a standard that we use in our cars. It provides us with an approach to software development. It provides us with an architecture, and it defines the most important aspects of automotive software for us. So we don't do that. Every company does it, does the development in a similar fashion. This is, let's say, it provides us, you can compare it, I think, to Lego. So Autosar is your Lego set where you have different Lego pieces and you can put them all together, and this builds somehow your software architecture of your unit in the car. So obviously, when we say that Autosar has all the most important parts of automotive software, it has to have diagnostics, right? Because I just said it's important in the car. Therefore, Autosar is present. Diagnostics is present in Autosar. Okay, so how does it work in Autosar? How does diagnostic stack exist in Autosar world? So, as we already also said, we've got, do I have a pointer here? Turn on laser pointer. Cool, I have it. Okay, so the pointer, or rather diagnostics. So we have the onboard on the right, which is the part that is inside the electronic unit in the car. So you have the airbag unit, the windshield wipers unit, the ECU, so the main engine unit. You have various units in the car. As I said, 100 of them, but depending on the car, more or less. And this unit on board of your car, it communicates with the outside world with a diagnostic tool. Again, your stethoscope, your OBD2 connector, and all this, all other layers of it, but with the use of the OBD2. So what use cases do we have? We have use case A, so service. So you got your problem with your car, or you need to do something with your car. You go to the service, you go to the shop, and they connect with the OBD2. They connect their huge tester or their huge diagnostic tool. They read some services. They interact with the car. They exchange information. So this is first use case, the service. The second use case is development. So that's me. I need diagnostic tool to communicate with the car, to retrieve, also to check if what I'm doing is making the car go good or bad, right? So yeah, I just, I upload my software in the car, and then if it doesn't explode, there still can be something wrong. So I still have to ask the car, are you okay inside of it with my diagnostic tool? And we have the manufacturing process, which is on the production of the car in the factory, right? So the car exits the factory, or rather it's assembled, and then at some level of manufacturing, we have to give some, so we have to communicate with the car and give it some information. So all of this communication that I just mentioned in Autosar, it's realized by the DCM, the Diagnostic Communication Manager. So this is the main module that is responsible for diagnostic, well, as the name, diagnostic communication. It's not a revelation. You can learn it by the name, but more about it a bit later, or actually quite right now. I was hoping for a joke because it's on orange, but okay, let's go. Yeah, so For those of you that were on my Autosar introduction, you obviously know what are the parts of Autosar. So on the top here, oh, I have my red thingy. So on the top here, it's the application layer. So it's the layer of the software that represents all the operation of your car, of the functions of the unit, right? So you can see here that you do have some monitors, you have some lamps, you have some upper layer modules that do something, right? So all of them, they communicate with the BSW, so with the basic software, so with the core of Autosar, let's say with the with the main core of your functionality here, and by the RTE. I'm not going to go into details here because this is more connected to Autosar. But what is the most important thing here is the DCM that we spoke about. So the DCM, again, it's responsible for the communication. Then what does it communicate with, right? We have the module of communication, has to talk with some layers. So first of all, it speaks with the diagnostic module on the application layer. So when we want to ask our car, how are you doing? Like what voltage do you have on your battery, right? Are you getting all the messages that you need? Are you okay? So then we communicate with the application layer, right? So we ask the application layer, are you fine? Then again, if everything is fine, we can just reply to the tester. So we have the COMM and PD router layers that then communicate with the bottom of the stack. They can be transmitting the messages on CAN or on Ethernet or any other communication bus that is available. And also it can communicate with the DEM. So the next layer that I'm going to speak about, but more about it later. So the process. This might seem scary, but actually it's not. So the process of diagnostics is this is actually quite interesting. So how does it work that, for example, BMW or Daimler or Ford or any other brand, how do we as developers, how do we know what kind of diagnostics do they want, right? So there are two options. This is what I also mentioned in my Autosar introduction. So one option would be write thousands of pages of documentation, right? So you can write all the ISO norms and documentation, and then as developers, as architects, we would have to read it, go through it, inspect it thoroughly, and then it will take years. So what is a huge advantage of Autosar is that we have a format that realizes it for us. So either BMW or any other manufacturer, they prepare a matrix of diagnostics. So they say a car will be diagnosed against this and this and this and that. We will retrieve following information from it, blah, 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 blah. So we have a list of services defined by the manufacturers. They send it to us in a defined format. We take it into our tooling, and then we apply it to our software, right? So this is a very nice way to communicate because it's automated. So it doesn't create problems that I read something wrong, or it was in German and I didn't understand it, or whatever else, right? So the process. Okay, so going back to the parts of diagnostics, right? So we mentioned we have, first of all, we have the tool, right? We have the stethoscope, which is our OBD2. We have a way of communicating with our car. So actually, what can we communicate, right? How can we speak with our car? So first part of diagnostics is actually the first part is telling your car what it is, right? So as I mentioned, the cars are part of life. So you know they have existential problems. They don't know what to do with their life. They don't know if they should follow their dreams or be an artist, and if they should go to Ireland and drink a lot of whiskey, or they should be a writer, or well, anything for that matter. So when they exit production, they don't know sufficiently about its meaning. They don't know if they're for Italian market or if they're for Chinese market, or they don't know details about their manufacturing. They do know that I'm a Volvo, I think, right? Because I was producing a Volvo factory. I know that I have all these units, but they're not yet coded. And this process is called variant coding. And what it actually is we simply tell the car all the requested information, including, for example, we can have one unit of hardware, so one piece of electronics for all the variants of the car. And then depending on the variant coding, we can enable or disable features. So if you paid for the cruise control that is automatic, we apply that the car realizes this. So we don't change the actual hardware. We just tell the car, please enable the cruise control, the Autometer, the adaptive cruise control, or how do they call it, right? So first part of diagnostics is telling your car what it is on production, right? Or production, or you can nowadays it's so cool that you can even buy it remotely, right? You can, I think in the Tesla, you can buy features then after you buy the car. So how it's realized underneath, right? So how do you tell your car what it is? So it has, we have things so services that we call routines and data identifiers. So data identifiers are pieces of data, as I mentioned. So for example, here you have examples of data identifiers. So a serial number of an electronic unit would be one. VIN number, right? You probably know or recall VIN number, that the vehicle identification number. Every car has one. So this is after the car leaves production. You tell it, this is your VIN, right? And please don't change it because it will be a mess. For example, odometer, right? Odometer is one of these values that also you set to 0 at the beginning, and that at some point you save it to different ECUs in the car, right? So we have our data identifiers, and we have our and we have our routines. So routines are just simply functions that we execute, right? So we can either read or write the data, or we can tell our car, please execute something, right? So please execute during the production. You can execute the test sequence, right? So after the car goes to the next station of production, we can send to the car, now please blink your beams, your lights, please honk your horn, and then please do some other stuff because you're under test in manufacturing, right? So we have routines and we have data identifiers. Okay, so I spoke about odometer. So for those, again, for non-Polish speaking colleagues here, it's just, so it says here, the Google search says how to roll back your odometer. By the way, I see already some questions. So the questions I'll answer at the end of the presentation. I hope that's fine for all of you, and we'll keep you here if you have to stay to get answers to your questions. So how to roll back your odometer, right? It sounds, sorry for the Polish here, but some things just sound better in some language, right? If you say I love you in French, it sounds better. If you curse in German or Polish, well, you know, the most famous the swear word in Polish. So actually some words sound better in some languages. So just how to roll back your odometer. I'm sorry, it just sounds good in Polish. Jak cofnąć licznik. And these videos, it's like it's a bit sad, but if you Google for how to roll back your odometer in Polish, you get a lot of results. If you look it up in English, you just get a few results that, oh, it is illegal to do it, so don't do it. So in Polish, we have some results, how to roll back your odometer. I promised you in some of the introduction to this webinar that we're going to speak about it. So how to roll back your odometer, right? So again, going back to some times that were simpler, the simpler times, a couple of years ago, we've taken the drill, we drilled, and the odometer was going down, right? So we just took it away, took it out. It was mechanical, so it was, you know, this is why we bought so many drills in Poland, right? And most use for them. So how do we do it right now? So we have, you recall, or you already know, routines and data identifiers. And you already know that we have our stethoscope to the car, so we have our OBD2. If you watched closely, the shape of the OBD2. The pictures where I shown you where it's in the car, it was similar, or rather in the same shape as we see here. Now, the next question that I was luring you to my presentation was, what's the difference between the $3 tool, diagnostic tool, it's a diagnostic tool, and that you stick to your OBD2, and a $10K diagnostic tool that is a professional one, that you can sometimes you cannot even buy them if you're not a workshop or an authorized dealership of a car, so they're limited only to the dealerships. But let's go back to the odometer, right? So unfortunately, no, it's not possible to change the odometer value with a $3 unit, or maybe not impossible. I think there are some smart guys that can do it with this, but I would say it would be really hard. But how to change it? So it's not as easy that you can just tell the car, here is your new odometer, right? Everyone would do it, and we would just have a lot of cars where you see that the car has 1 million miles on it, and then the seller says, oh, the lady just drove to the church and back, and it just has 50,000 kilometers. So how to do it then? Just a second. I have to hydrate. Oh, all of you hydrate. I've heard that if you hydrate, you're doing better on your life. So I'm told. Road odometer. So it's not as easy as just sending to your car, here's your new odometer. So how it's actually done is that, first of all, you have to pass security, right? So first of all, you have to authorize to your car. So you have to say, dear car, I really am a good tester, and here is my security certificate. Here's my fingerprint. I've registered in the manufacturer service. Here is my key, and please authorize me, right? So then the tester authorizes you, and this is the main and first difference between these testers. So the tester on the left, the Bosch one, or any of the brand, doesn't matter, but the more advanced ones, they have abilities to authorize themselves for specific cars, and they can change session of the car, and they can tell the car that, please, now you're in a special session where I can do more with it. I'm not telling you that you would buy this one and you can change the odometer, but you will be able to do more with the car. You will be able to tell the car what it should do with its life, right? So first of all, we have to unlock the security, and then we have to, if the car has, or if the unit that we're speaking with has this functionality, we can change the odometer with special sets of routines to first put it in production mode, to assume that we're exchanging something, and then do a lot of stuff. Mostly it's very hard to do, but obviously there are ways to do it. So first of all, security, then extended sessions, then we can execute some routines, and then we can try to do it. The advantage of it is that it's not as easy. And then there are some ways that you can actually retrieve the old odometer, but more about it later. So the next question that was in the agenda, how to add horsepower to my Passat. So we already spoke a bit about exchanging information with the car. And we've just said we have routines, we've got the OBD tool, we have the stethoscope. So then I mentioned isonorms, right? I haven't told you about an isonorm yet. No, I just, I mentioned about OBD. So how to add horsepower to my Passat? Well, the answer is obviously UDS. So UDS is Unified Diagnostic Services. This is, you can see on the bottom, it's a red one. So please bear with me, do not go away. It's going to be short and concrete. I'm going to try to just explain you what you need to know about the norm. So the norm is ISO 14229. Please do not remember the number, I don't. And please do not remember the services IDs, I don't. So what we have to know about it is it is an ISO norm that defines diagnostic services. It defines diagnostics to all cars. So all that we said, telling the car what it is, the routines, the identifiers, the data identifiers, all of it is defined in UDS. And you have to see that, or rather you notice probably that I used wonderful colors here I split the services into 4 categories. So first category, you see here with this, I want to say green, but I'm a guy. Okay, so this is green. So green, on the top, you have the diagnostic session control. So first of all, I mentioned security sessions, or rather changing sessions. So you have a couple of sessions in the default session. So in the session that you are at the beginning, you can do just very limited amount of activities. Then if you want to change session, you have to use the service to tell your car, please go to, let's say, extended or programming session to do more with it. Now, you cannot change the sessions without security access. So you cannot just tell your car, well, you're in production, right? Again, we need security to do this. So the changing of session goes together with security access. So you have to introduce yourself. Hello, car. I am really a tester from Daimler or Volkswagen or for anything else. Please go to some session. Then you can also try to control the ECU, the part of the car with ECU reset. So you can tell the unit, please reset yourself. Yeah, it might just listen. So this is the first category, kind of like controlling of sessions and the life of the unit. Then you have the clear diagnostic information and read DTCs. Now, these are not all the services from UDS, but most of them. I mean, not most of them. The most important ones, the most relevant ones for a discussion here. So we have the section, the orange section about problems. So this is where we're going to go. We're going to go to some description about the DTC, so diagnostic trouble codes, so the problems with your car. So this is the part that reads them and clears them. We have the read-write data by identifier, just what we just discussed. We have routine control, what we just discussed. And also at the last but not least, we have the routines that are connected with software loading. So nowadays, you have, I'm going to switch to the next slide because so not too scary with the ISO norm. Green again. So, in your cars right now, it's really cool. You have the OTA. So you have the over-the-air update. So you drive around your car and then your rear view mirror blinks and you say, well, your software has been updated to the newest one. And now you have all these new cool features, right? So how it works, it uses UDS over the air, so over the GSM network. It unlocks the security, it prepares the software for you, and it flashes some units in your car via software loading. So software loading is simply way of updating your car, right? Okay, so we've got our interface to the diagnostics. So we've got our connector. We've got the first big use case that I mentioned. So we've got telling your car what it is. So now the second important aspect of diagnostics, errors, right? Errors are important. We need to know what happens with the car if anything goes wrong, right? We need to ask it how is the car? How are you? What's up with you? Do you need a blood test? Do you need an oil test, change, whatever? So we need to ask the car how it's doing, right? So errors, yeah, you've seen probably most of you've seen this these graphics in the dashboard of your car, the check engine. Probably when you went on a party and then you wanted to go home, you ordered an Uber and you were cheap, right? I just after a couple of beers, I just take the cheapest option, and then the guy comes and I'm like, I'm gonna die in this Uber. He says it has the car has check engine. I knew I should have taken the select option, right? I should have been cheap, but well, what you gonna do? So you have this check engine, which is actually connected to a DTC, so a diagnostic trouble code, which we're gonna discuss in a second. So DTCs, diagnostic trouble codes, are a way of telling your car, or your car telling you rather, that something is wrong. So I thought also a lot about this one, so please bear with me. Back to my comparison to human and life and everything else. So I came up with this. You can judge it if it's okay or not. So DTCs in our car, we can separate into 3 categories that are similar when you go to the doctor's office. When you go to the doctor's office, in my life I've met with a couple of let's say results. First one was that the doctor said, well, you're feeling a bit off. We're gonna do a blood test, right? He did a blood test, and then it came like, well, really, is everything's fine. Your cholesterol is a bit higher than it should have been, so I'm gonna give you these pills, right? So and then he gives you the pills that paid for his skiing trip last year. You buy them, and then you take them, and you don't really feel better. Your cholesterol is a bit better, but there was nothing wrong with you at the first place, right? So this is the first category. These are the DTC. So these are the errors that your car might show to you. They might come to your attention, but then at the end, you can just delete the error. So you can connect your diagnostic tool. You can say, please delete this error. The error goes away. And actually, there's nothing wrong with your car. These are the errors that might, there was too high humidity. You rode over a pothole, and some harness was, shortly interrupted. There was a power spike in your system, and something went wrong. So this is the first category. Like, there's nothing really wrong, and so why do I want to pay for my doctor's skiing trip? I don't. I mean, well, depends if I have. Yeah, no, never mind. So first category is this. Second category is that you go to the doctors and you say, I feel really ill. So he makes a blood test. The blood test comes, it's bad, and then he says, well, we have to have a surgery, right? So there is something wrong. We have to do something with you to make the results better, right? You go to the surgery, you have the surgery, then everything is better. So this is a type of error where your car breaks down. It has a problem, actual problem with the mechanics, with the electronics, with the software, with anything. It has to be fixed, and then afterwards the DTC, so the problem that surfaced that informed you about the issue, it has to be also deleted, but the root cause has to be deleted as well. So it's not like you go to the shop, you delete the errors, and everything is fine. No, it's gonna pop up again because you don't have four wheels. You have three wheels, and the car says I want to have four wheels. So if you delete the error, you don't add the wheel, right? So this is the second category of DTCs, or your real life problems. The third category that I came up with, what was the third category? My worst one. So that you go to the doctors and you say that, I have this issue. And then he says, okay, I'm going to do blood tests, and then nothing is there. And then he says, I'm going to do this inspection, and nothing is there. So he says, like, sir, I think it's just your nature, right? And then you leave the doctor's room and like, what the hell? I'm feeling wrong. And then he says, it's my nature, right? So then, then as soon as you leave, probably he's gonna Google, like, is a person supposed to have three kidneys or something, like, And by the way, my wife has three kidneys, so hi Yulka, you can have that, or one of them is double, or whatever. It's not connected to Autosar, so just fun fact for you. So the third category is actually surfacing a lot in cars right now, unfortunately, because due to complexity of car and software in it, there are multiple errors that can cause cascades, and one error of one unit can cause a cascade that creates other errors. And then even if you delete the error, and then you don't know what is the real root cause, right? You can exchange half of the car, and then you will still not know what is the root cause. It takes a lot of time and inspection to do it, and this is why we need reliable and good diagnostics from Autosar. So it's really important that we focus on it. All the software development people that are here, please take it into your consideration that it's really crucial that we keep the quality of our diagnostics high. So we don't tell our client this is just your nature, and we don't go to the car workshop and he says we're just going to give you another car, right? Because it's cheaper to give you another car rather than exchange half of the current one. Okay, so DTCs, so the problems with your car. Of course, there is an ISO norm saying defining DTCs. So first thing that is in the ISO norm is the ID. So if you read the errors from your car, you're going to know the ID of the error. The ID of the error is already defined with some codes in it, right? So it can tell you a lot already by its ID. So it can tell you if it's, for example, from the chassis, from the body, from the network, from the powertrain, all this additional information. You can then Google them. You can feel like in the old times where you fixed the refrigerator. So we have first the ID, right? Then, really important one. So please, for all of those of you that are not really into software development, but you do have a car, you can focus. You can remember this one. That when you read the error code from your car, you have its ID and then you have its status. So the status is very important because it tells you a lot of information. First of all, it tells you, is the error occurring right now in this cycle? Cycle in automotive means the operation cycle. It means that from the time that you open your car, you go in, you crank up the engine, you start the engine, it starts the operation cycle. Everything goes up. The car wakes up from sleep, everything goes up. Then afterwards, you turn your car off, and then everything. It's not so the operation cycle. It doesn't end exactly at the when the ignition goes off. It goes off. So the operation cycle goes down when you close your car. You will exit it, and everything shuts down slowly, gradually. Then after some time, the car goes to sleep mode and the operation cycle is ended, right? So the status of this DTC will tell you if the error is currently there. So if right now you don't have a wheel, right? If you test it whenever you test it, it's gonna say, man, you have no wheel. Like what do you want what do you want me to tell you? The wheel hasn't reappeared magically, right? So test failed, which is the bit 0 that you see here, tells us if it's failed within now when we're checking in this operation cycle, right? But you have also other information there. So it can tell you, for example, that the test was failed, but previously. So now it's okay. Now you do have the wheel, but 1 week ago you didn't have the wheel. So I saved it. I thought it's important to save and to tell the mechanic that you haven't had the wheel since for a week. So it tells you a lot. So you can find out on the internet, you have the link below. You can see what kind of information, so what kind of state does your error have? Is it now? Was it 1 week ago? And also for all that have a car, it can happen, fun fact and a hint, that you can have an error. It goes away. Let's say the root cause of the error goes away. Still, you have the error in your car, but you don't have to immediately. So it's not red and you read on the internet that it's fine. You can leave it there. And then every DTC has a factor that is called a healing cycle counter, which basically tells us after how many operation cycles, if the error is not still there, we should delete it. So sometimes or most often it's set to 100. So this is why sometimes on forums you can read that, oh, in my Fiat I had this problem and then it was okay. And then after 3 months it disappeared, right? So what happened? The healing counter, it reached 100. So 100 times of ignition on off, going up and off and go to sleep. Then the car says, you know what? It's 100 times. Forget about it already, right? Get over it. So the status is this one. What do we have more? So more information means better knowledge about what happened. So what do we have there? We have snapshots called also freeze frames and extended data. Both of these are giving us information, more information about the DTC. So it tells us, for example, at what speed was the car when the error happened, what odometer value was there, what was the temperature of the coolant when the error appeared. So it gives you a lot of more information what has actually happened, right? So bear in mind this is interesting, and also fun fact and hint. This is one way of checking out if you have bought a crashed car. So if, for example, you read the errors from the main unit and it says doesn't have errors because the guy that sold you the car, he removed them, right? But then you can also retrieve errors for various units in the car, and you can also retrieve errors with the odometer value saved. So for example, if you have a DTC that has a different odometer value than the one that is in the main computer, you can say, the odometer was broken. Then also you have information about the airbags and other important factors in the extended data or in the freeze frames. So retrieving information from various parts of the car is good in this aspect, that you can get more information what has happened with the car. So going back to Autosar, I have to speed up a bit. So I don't know if you have a hard stop, probably not, but I'll try to keep up with the time. So Autosar Obviously, as we discussed, it offers you various tools for diagnostics. We discussed one of them, the DCM. It allows you to communicate with the tester and send all the information that it needs. You've remembered this slide. I told you that I'm going to speak more about the DEM. The DEM is the Diagnostic Event Manager. If I recall correctly the name, I never remember the names. I just remember what it does. So the DEM is responsible for for checking all the events that are happening in the system, right? So it checks, it communicates with the upper layers and says, okay, is everything okay? Is the engine still where it's supposed to be? You know, is the temperature okay? Are you retrieving all the crash signal that you're supposed to retrieve? So it asks the application layer, has everything that is supposed to happen happened? If something is off, then we register an event. Well, hey, we have lost a wheel, right? I think it's good that we save an error because we have no wheel, right? So this is what happens. This is what the DEM does. It initiates a function set event status and it says failed. So do we have a wheel? No, we failed at having wheel. Yeah. So we communicate with the application layer. We communicate with the communication layer, obviously, because we have to tell if the tester asks, we have to tell them we've lost the wheel, right? Go to the sidewalk or the side road. So it communicates with the application layer, it communicates with the communication layer, and then obviously it has to communicate with some additional layers as well. Some of them I'm going to describe to you. I think I don't describe the NVM manager, which is also very important to tell about, because the errors that are saved in your car, going back to my GlobalLogic colleagues from Krakow, if you disconnect your battery from your car, yes, some of the DTCs can disappear, but only the DTCs that are very, let's say, categorized as light DTCs that are not influencing the safety of the driver, that are not influencing any major operations. These ones, they can omit the NVM, so the non-volatile memory. So the memory of the car, it can skip that. So if you disconnect the battery, the car is going to forget that. So yes, you can do it with some cars. I mean, with some problems, but only the slight ones, right? The more important ones are saved in the memory. No way to delete it other than the service clear diagnostic information that you need security to do. This is why you pay, $30 to delete your errors. So we have the DEM, so the events that are being registered by the system. What do we have next? We have the FIM. The FIM is also quite interesting module. It's not always used, but it's a very cool one. So please remember about it. So FIM is the function inhibition manager. So I think some of you maybe, hopefully not, but maybe I did. So some of you encountered a situation where your car had a problem and then it had entered this emergency mode, right? You cannot go over 40 kilometers per hour. Your brakes are really hard. You cannot push them. You have to push them really hard to brake. You have like an emergency mode, right? So how it's called in let's say Autosar in diagnostics terms, this mode is called a limp in home mode. By limping in, with crutches, where you have to go to home. So the speed is limited. There are some limited functionalities of your system because we have, and what it means is we have encountered a critical error and we have to limit the functionality of the car to make our way home and not to endanger the driver. So this is the function of FIM. The FIM detects from the DEM, it has information, something has happened. And what it does, it prevents execution of some functions. So if it says FIM is on, then no, you cannot go over 40. So even if you press all the way to the floor with your gas pedal, it won't accelerate, right? So this is an important module as well. So we have our interface, we have our DCM for communication, we have our DEM for the events, we have the FIM for if it happens, what to do with it. And I think last but not least, the DET. Oh no, there's one more. So DET of the abbreviations. Autosar is all about abbreviations. So this is the development error tracer, if I remember correctly. Doesn't matter the name. What it matters is what it does. So the DET logs errors in the system, and it's kind of like a ninja module. It registers some errors from various spots in your software, and it allows the developer to sense them. So you can configure it in very special ways that you retrieve a lot of information from the execution of the software, but this is mostly for developers. So this is not really, you disable it for production. So it's just for software development. After production is on, you forget about the DET, or you should at least, because it modifies the operation of the stack. So remember that. And I think now the last module that I wanted to discuss with you, the DLT. Quite cool module. It's getting more popular nowadays in Autosar world. So it allows us to get traces and logs from the car. And in some cases, you can enable it after production. So what you can do, it provides like a black box of your car. So you connect to the OBD or to any other interface that you, if you're, let's say, more advanced and you know where to stick your probe, you can connect to the DLT. You have to unlock it, so it's always blocked by security. But if you can unlock it, then it will give you a lot of logs from the car. So it simply allows logging, right? It's defined by Autosar. It's, as you can see here, it doesn't matter which communication bus you use. It can transmit on any. If you want to know more about it, I've just written an article about it. My promoter said that I should promote it. I think if you quote it, it will give me some points. So quote me, please, if like the article. There's going to be a link here. No, it's not going to be a link. Okay, so this is the last module in the diagnostic stack of Autosar. So to summarize, we've got our probe, our stethoscope, the OBD. Then we have functionalities of diagnostics. First, telling your car what it is. Second, errors. Third, which I haven't discussed because we had no time, maybe we can do another session because it's really a huge topic, software loading. So I mentioned it, but it's advanced that we need to speak more about it. If you like, maybe another presentation we can do. So what is left? What is left? I would like to conclude with this one. This is a scene from a show that I really like, Westworld. I mean, how can you not like it? It's Anthony Hopkins playing Dr. Robert Ford. So let's play it. It's just, I think, 30 seconds. So let's hear it.
It's the code you added, sir. The reveries. It has some
mistakes. Is the word you're too embarrassed to use. You ought not to be a product of a trillion of them. The evolution forged the entirety of sentient life on this planet using only one tool, the mistake.
The mistake. I really like this quote. Now, I'm not telling you that you should follow evolution and just create your software with one tool, only the mistake. But please, what I can tell you is that first of all, you have Autosar there to help you with your mistakes. So you can have Autosar to do the diagnostics, so you can rest your weary eyes on Autosar pillow. And what I can tell you is that please learn on your mistakes and have Autosar to help you. And with this aspect, I think we can.
It's the code
we can,
you added, sir.
we can turn it again. No, I want to go to the next slide. Yeah, thank you. So this is the last slide. I think now we can have the Q&A. So thank you everyone for your attention, and let's get to the questions. Oh, terrible refresh rate. Sorry about that. I hope on YouTube it's going to be better. I think also we can share the presentation. I'm not sure if this is up to Veronica. So let's go through the questions. So question number one from Roman. Does this architecture implies that every item can communicate with another through gateway? I'll answer live then. Yes and no. So what it implies is that we can have inter-node communication, but how it's actually done is with with addressing methods. So in UDS we have two addressing methods. One method is functional addressing, second one is physical addressing. So with this function, with these addressing methods, you can travel through the car and communicate with special frames. So with diagnostic frames, you can communicate with most of the units. Now it doesn't relay, so the routing of the messages themselves is not for everything. So it's not that every unit can communicate with every unit. But the special diagnostic messages are relayed in a gateway and slaves that are communicating to the gateway, and then by the gateway they can communicate with some other unit. But the messages, they have to be predefined depending on the communication bus. So CAN, LIN, Ethernet, and so on. The configuration in the car specifies who can communicate with whom, right? So it's not all to all, but in theory, it would be possible depending on the communication bus. So first question, just Bartek, how can I learn Autosar independently? That's a good question. So first of all, you can always watch my Autosar introduction video. Then, unfortunately, there is not a lot of ways to, let's say, learn it in a nice way. So the best way, obviously, since GlobalLogic is organizing this, so you can join GlobalLogic. We have this cool program that's automotive, that's called Autosar Academy. That is basically if you're a software developer and you have some experience with software development, then you can join us and then join the Academy of Autosar, and we can teach you. And this is the best way to do it. Learn it on the job, right? You can read the documentation of Autosar, but it's hard to learn it, let's say, from theory only, right? Okay, answer live, yes. Then the next question, the DID and RID, so data identifiers and routine identifiers number, are OEM specific, or is it as per ISO standard? Jein, as the Germans like to say. So yes and no. There are some numbers, so some IDs defined by the standard. Like I think the VIN is one of them, that is F190. So this one is some part of them are defined by the ISO, but there are some custom ones. So there are also some really, like, I think there are ranges in the ISO where you can, this range is reserved for this particular ones, and all the other ones you can put in this range. So yes or no. Answer live, done, bam, bam. Okay. Is there any share path to download the ISO? Yeah, no, there isn't. Unfortunately, ISO, I think it's Swedish. I don't know, but ISO as in general is paid. So we have to pay to get the ISO norm. So you have to pay to get the ISO norm. You can, I think, buy a membership of the ISO company, whatever, and then you can also download it. But I think that the UDS, you can try to Google it. It's illegal too, but I've heard good things about it. Bam. Okay, live. What are the common configurations for DCM? Not sure I understand the question of common configuration for DCM. So the DCM comes, the DCM supports the UDS. So DCM supports all the services. So read, write, routines, DTCs, ECU reset, and so on. So this is the, let's say, the part that is known by everyone because it's the standard. And then it takes, so what DCM does, it takes the part of the standard. So it takes the services that are defined, and then it takes the extract from your car manufacturer as the second thing, and it takes your, you can also change it manually. So it takes those three things and it combines them. So it knows that we have read by identifier from the standard because it's defined, and then it takes all the IDs from the matrix that you receive from the car manufacturer, or you can add some stuff to there. So you can, so the DCM knows that we have read data by identifier, and then it knows that you have IDs 1, 2, 3, 4, 5, 6, 7, 8, and then these IDs are using this service. So this is how it's, let's say, common is the services themselves, and custom is the IDs, the particular run usages of each service. I hope this is what you meant. If not, please write on our question. I'll specify it. The DET, Diagnostic Error Tracer. Yes, it was Diagnostic Error Tracer, but then I think in the latest release of Autosar 4.4.0, it changed to Development Error Tracer, since it's supposed to be used for development only. So the first rule of Fight Club, or rather DET, is that you don't talk about the DET. Now it's that you disable it for production. Okay. Is there a way to check if the odometer value has changed without security codes? Yes. Yes, but it's tricky. So how some car shops do it, or some, let's say, skilled people are doing it, is that they know which memory location at which ECU is the odometer. So then they can hardwire to these ECUs and then read the value from the memory directly. For example, this is one of the ways. But all of the ways, let's say, without security codes are just gray zone. You're not supposed to do it. So there are ways, of course, if you're not supposed to do something, everyone does it, but it's not that easy, right? It takes some skills, so I can give you some names. Okay, I've got a question about testing of Autosar software during development. Okay, what is the ratio between automated and manual tests? And then which languages and tools are used for testing in such projects? Okay, good question. So Autosar software is not that different from normal software. What is the only difference between Autosar software and non-Autosar software is that with Autosar software you don't have to test the core because it's certified. So you assume and you know that the core is tested, certified, and you don't touch it. So this part you don't have to test it. So it limits your testing time, right? So this is the first thing. Then what is the ratio of automated and manual tests? Well, there is no ratio. It depends on the project. The more automation you get, the better, in my opinion, but that's just my opinion. So I like to automate everything, starting from my coffee machine. But in real life, obviously, you cannot automate everything. You have some special use cases. So I would say automate as much as you can, but sometimes you have to still do it manually. Which languages and tools are used? So tools, you have a lot of tooling from Vector. It depends also on which layer of testing are we speaking. So if we're speaking about system tests, integration tests, or unit tests, there are various tools for each layer. So for system tests, for example, or integration tests, you can have Vector tools, or you can have some other manufacturers that do it, Canoe, or others. For lower layers, so for unit tests, integration tests, you can even employ Python, you can employ C#, depending on the use case. So it depends on the layer, because automotive software is really huge and it has a lot of layers. So depending on the layer, you use different tools for it, right? I hope this a bit answers your question. If you want to read more about it, please look up vModel. That is the process of automotive, and it will help you to understand at what layer you use which tests, right? Or write us an email, or apply for work in GlobalLogic, so we can teach you. Okay, and the next one, how the OBD2 devices are authorized. Is it like an HTTPS? We have trusted certificate, and CAR-I verifies the certificates of a diagnostic tool. Yes and no. So depending on the service, yes, we use a similar way that we have certificates. The certificates, let's say, introduce ourselves. At which role do we have? So are we development? Are we supplier? Are we production? So depending on the role, we introduce ourselves as the tester with the security access routines of the UDS. And then if the unit says that we have enough authorization, we can unlock some features. But then also it is quite tricky, because depending on the unit, some of the features might be having additional security, because they say this is so important that you don't mingle with gas pedal, that we have additional security that you have to bypass to do some stuff, right? So the authorization is very custom. But overall, yes, I think the comparison to certificates and HTTPS more or less it's in this vicinity. Okay, could you please make a session about network management and PNC? So partward network. Okay, I'll try. It's a complex topic. Session and network management is connected with the life cycles that we mentioned and with sleep modes and a lot of interesting things. PNC is also connected with network in the car. Great topic. I'll try to work on it. Dependingly on the time, I will try to prepare something. What are examples of routines? So routines are just, as I mentioned, functions that are being executed by the unit. So an example of a routine would be perform. So as I mentioned, the flashing of the light. So either some test routines or a routine could be verify signature. So for security purposes, we can have a routine that says, please have this procedure of events that will verify the signature for us, unlock something. Or it's simply anything that's not simply reading or writing of a data, it's more complex, it's some execution. So all of the executions they're based on the routines. Okay, done. Is there are they, sorry, is there every DTC I did to read it? Okay, I think I understand. So what you mean is that, is there a DID? So is there a data identifier for each DTC? No, these are two topics. So one topic is the DID, so the data identifiers, which you read and write, but they're not connected to errors. The DIDs is some custom data, like what kind of GPS network are you using? In what country the car is supposed to drive, right? Is Germany, Italy, or Poland, or whatever? So this is the information, and the errors, the DTCs, they are separate service in UDS and separate piece of information. So you use two different, I'm waiting now. You use two different ways to access this data. There is no relation that a DID is a DTC. No, there are two different entities. Can you give a short explanation about ODX? Short explanation. Well, ODX is a format of files that support diagnostics. I would have to speak more about it. So it's with Candela Studio also you can have support of ODXs. It's a way of transmitting diagnostic information. So you can transmit the diagnostic information with a means of IRXML, with a means of CDD, or with a mean of ODX, or SMRD. There are a lot of formats that you can use for diagnostic. ODX is one of them. I can give you more details, but I think it's really specific. So you would have to write me an email. We can chat about it, because it's really like one of the ways to. But overall, in general, it's one of the way of describing the diagnostics, right? Of describing the specific diagnostic of a system. Why do we need UDS when we have OBD? Planned. Okay, sorry, but Veronica, do not submit more questions. Okay, last 4 ones. Okay. I'll try to be quick. Why do we need UDS when we have OBD? So UDS is the standard that defines the communication and all the service and so on. OBD is something different. So OBD is onboard diagnostics. So they are touching two different subjects. So UDS itself, it doesn't tell you how should you retrieve. It's a software norm. So OBD is so much more than this. So OBD defines, first of all, the physical layer. So the shape of the connector, the pins, the electrical levers, but also some other information. So there are, let's say, these are standards that are touching different layers, physical layer and software layer and some other ones. So these are just two different topics, let's say. Does GlobalLogic provide online courses or diplomas? I'm
answering that right now. I will type the answer.
Cool. Okay, cool. Okay, so I'll skip this one. Is C++ used for development using Autosar? If yes, are there special compilers? So first part of the question, yes, C++ is used for development using Autosar. there are two Autosars, Autosar Classic written in C and Autosar Adaptive written in C++. There are some differences between them. Again, please refer to my Autosar introduction video. I describe it there. Shortly speaking, yes, you can write in C++ in Autosar Adaptive. No, there are no special compilers. You can pick any compiler you like. It just has to compile the code. It has to just follow some norms of automotive, but it's nothing special really. You can also use GCC. Okay, bam. And then, is there possibility to sniff OBD and authentication communication and replay it? Sketchy question. Yeah. In theory, yes, but in practice, we're already using encryption, so you cannot sniff it simply. There are ways, so unfortunately, it was possible. So this was one of the ways, as you use for unlocking the car, so you extend the range of the of some keys, and then the key sends the information, or you catch the information from the key and replay it to the car. So in some cases, yes, but automotive is moving away from it, and we're encrypting everything. And also, if we're doing the same security measures, which are not a secret, but we're using freshness counter of the messages, so it will be detected that the freshness counter is off and we have lost some messages, and you're doing a replay, so man in the middle attack. So in theory, yes. In practice, no. Or the other way around, but depending on the system. Can I read some debug information through diagnostics? For example, some internal variable value. No, you cannot. So if there is, or maybe rather otherwise. So some services that I skipped on UDS are, for example, read memory by address. So I mentioned read data by identifier, but there is also read data by address. So by this means, if it's unlocked, but it's not by default, if it would be unlocked, then you can send a message, please read me the address, the memory address from here to there. It should reply with the information. But due to security measures, these services are disabled. So you would have to, or sometimes even not implemented in some use cases. So in theory, UDS allows it, but it's not used due to security. Whew. Okay, last one. I hope I answered in a way that satisfied your questions. And Veronica, back to you. Thank you, everyone.
Yes, we are like almost half an hour after the time, but thank you for those who stayed with us. I see that it's quite big amount of people. So thank you very much. We hope you liked this webinar. And as I already said, it will be available on our YouTube channel, so you can subscribe to get notifications and check for other activities that we are uploading there. So again, thank you very much for bearing with us over the time, and thank you, Patryk, and see you at another webinars from GlobalLogic.
Thank you. Bye.
Bye.